Hello everyone, this is Dr. Lennon, and we'll be going over the test 2 review. So the first one, we have twice the difference of a number and 10 is 54. Find the number. So remember, when you have an unknown number, basically that's what you're going to treat as your variable x, and is typically stands for equals. So you have twice the difference of a number and 10, so 2 times the difference of a number and 10 is 54. So that's going to be 2 times the quantity, so we need parentheses. So we need x minus 10, and this has to equal 54. And then we go ahead and just use algebra to solve. So we distribute the 2, so we have 2 times x minus 2 times 10, which is 20. This has to be 54. And we want to add 20 to both sides. So we have 2x equals 74, and then we go ahead and just divide both sides by 2. So we have our answer x, which is equal to 37. If you want, you can go ahead and check that answer back in the original problem. So what do I mean? If you want to do a check, you can go ahead and plug 37 back into the original problem and make sure that comes out to 54. So you can do 2 times 37 minus 10, and that's equal to 2 times 27, which indeed equals 54. So you know your answer checked out. You don't have to do the check, but if you want to be certain, it's a good thing to do. So let's go ahead and look at problem 2. So we want to find 3 consecutive odd integers whose sum is 51. Now, the only thing that's really important here is if we want to label our integers. Consecutive means they're next to each other, and odd numbers have to be 2 apart, like 3, 5, 7, 9. Those are all odd because they're not divisible by 2. So basically, our 3 numbers, so if we write down the 3 integers, we could write them down as x plus 2, that's 2 away, and then also x plus 4. So basically, if you add all 3 of those together, you should get 51. So x plus 2 plus x plus 4 equals 51. And then we just go ahead and simplify. So we have 3 x's, and 2 and 4 add to 6. This equals 51. So we go ahead and subtract 6. And we get 3x is equal to 45. And then we want to divide both sides by 3. So when we do that, we end up with our answer, x is equal to 15. And again, you could check this the same way that we did in the previous problem. We could just go back to the original equation and say, okay, 15 plus 15 plus 2 plus 15 plus 4. Check that comes out to 51, which it does. Okay, so for this third problem, we have Sean that wants to invest $15,000, and basically she is going to invest it in 2 accounts, one that's earning 4.5% annual interest and one that is earning 1.8% annual interest. So basically, we want to see how much would be invested in each account if the final earnings came out to 4.05%. So basically, we want to have our 2 accounts. So let's let A be the amount invested at 4.5%, and B be the amount invested at the 1.8%. So basically, we have 2 equations that we want to write down. We have our total investment equation, so we know if you add the amounts A plus B, we should get 15,000. So this is the total amount equation, and then we also have a total interest equation. So if you do 4.5% as a decimal, that's 0.045 times A. That would give you the interest from account A, and the interest from account B would be 0.018 times the amount invested B, and that would equal the amount that you're anticipating earning, which would be the 15,000 times the earnings. Let me write that in the other order actually. So the total percent yield should be 4.05%. So we have 0.045, 4.05%, just move the decimal 2 places, multiplied by the 15,000. So we could write that number down. So let's just go to our calculators. 15,000 times 0.0405 comes out to $607.50. So 607.5. And then what we want to do on the other side is replace one of the variables. So let's suppose we have this equation up here, a plus b equals 15,000. Well, that's the same thing as saying, well, a is 15,000 minus b. So we can replace a by 15,000 minus b. So this can be written as 0.045 times 15,000 minus b plus the 0.018b. And now we have an equation with only one letter, so it can be solved. So we do our 0.045 times 15,000, which comes out to 675. So we get 675 minus 0.045b plus 0.018b. That's equal to 607.5. So we have 675. We can put together the two b terms. So we have 0.018 minus 0.045, which comes out to negative 0.027b. So minus 0.027b. And this equals 607.5. So now what we want to do is subtract 675. So we end up with minus 0.027b, and this is equal to negative 67.5. So we divide by the negative 0.027 on both sides. So we get our value for b, which comes out to $2,500. So basically, account B has $2,500 invested, and we know A is just going to be 15,000 minus the 2,500. So account A had an investment of $12,500. So these are the amounts invested in both accounts, which is what we're trying to find. So that was a bit lengthy in the algebra, but the main thing is to label variables with each account, interest earnings, and then write down two equations. One equation, a plus b equals 15,000, giving the total amount invested in each account, and then an interest equation where we have the interest rate times the amount invested in A plus the interest rate in B times the amount invested for B plus our total interest yield times the total amount invested. So that's where we get the equations, and then we substitute for one of the letters and solve the problem. So let's go ahead and move on to the next example. We move toward the geometry portion of the review. So this first one is not so bad. Basically, we know the angles of a triangle, A plus B plus C. If you add the three angles, you get 180 degrees. So in this problem, we know two of the angles are 14 and 65, so we want to find the measure of the third angle. So we just replace two of them with the measurements. So 14 plus 65 plus C is equal to 180. So we end up with 79 plus C. This is equal to 180. Subtract 79. So we know that angle C has a measurement of 101 degrees. And that's all you have to do for that one. So for number 5, we're applying the Pythagorean theorem. So what does the Pythagorean theorem say? Well, in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse, meaning the longest side or the side opposite the 90-degree angle. So a right triangle means it contains a 90-degree angle. So in this example, basically we're missing one of the legs. 17 is the hypotenuse and 15 is the other leg. So we can say a squared plus 15 squared is equal to 17 squared. And then once the setup is correct, we just do the algebra to solve. So we have a squared plus 225 equals 289. So we subtract 225 from both sides. So we have a squared is equal to 64, which means a is equal to the square root of 64. So we get our missing side. A is equal to 8. Again, we don't have to worry about any plus or minus here because we know all the lengths have to be positive values. So that's all you have to do there. Make sure your hypotenuse is on the right side of the equation, plug in the numbers that you know, and solve for the one that's missing. All right, number 6, we have the area of a triangle. So we just need to remember the area of a triangle formula, which is 1/2 times the base times the height. So you need to know the base and the height. Sometimes you may need to use a Pythagorean theorem to find the height if it's a right triangle. Otherwise, you have to find it with some other methods. Often trigonometry is involved in more advanced classes, but in ours typically we'll be able to see it, or there should be some way to use a Pythagorean theorem to find it. So in this example, the area of this triangle, we have the base of 5 and the height of 12, so we just run the computation there, and this comes out to 30. Technically, this would be units squared if it had some sort of like measurement like inches or meters or centimeters or something like that. If there's no unit, you can always just write generic units the way I did here, units squared, but that's all there is to finding the area of the triangle, nothing too tricky. This one involves some geometry as well, but it's kind of in a word problem form. So we have a rectangular rug, and they give us the perimeter. So for the perimeter of a rectangle, something that looks like this, if we have length here and width here, then the perimeter is just adding together all the sides around. So our perimeter is 2L plus 2W. So we know the perimeter is 240, so 240 equals 2L plus 2W. And then actually you can simplify this a bit by dividing by 2 on both sides. So you'd end up with 120. 2L over 2 is just L, and 2W over 2 is just W. So we have 120 equals L plus W. So that's what we can learn from the perimeter. And then we have this other sentence here. The length is 12 more than twice the width. So what does that mean? That means that L means equals, 12 more is 12 plus, twice the width. So we have one version of L here, and if we solve for L in this perimeter equation, we could subtract W and get 120 minus W equals L. Then we can put these two equations together to solve for W. So we can replace L here by 120 minus W, and then this is equal to 12 plus 2W. So we can begin by adding W. So we have 120 equals 12 plus 3W. And then we can go ahead and subtract the 12 to move the numbers to the left-hand side, the regular values. So we would have 108 is equal to 3W. And then to solve, we just divide on both sides by 3. So we end up with W is equal to 36. So that's the width. Don't forget to solve for the length as well. So you can use either of the two equations to do it. We could use the one at the very top here. Length is equal to 12 plus 2 times 36. So our length would be 84. Did they give us units for this problem? I believe they did inches. So actually we could say, okay, this is 36 inches and this is 84 inches. So those are our dimensions. Let me clean that up a little bit. I don't like the way that's written. So 36 inches. And then you could check by plugging back into the perimeter formula if you want. Twice the width plus twice the length. Does that come out to our 240 inches? Well, twice 84 is 168, and twice 36 is 72. So 72 plus 168 does come out to 260 inches. So I said 260, I meant 240. So 168 and 72 would come out to 240 inches. I don't know why I said 260. But anyway, so that's it for that word problem. Remember the perimeter formula for a rectangle is twice the length plus twice the width. And then we can write down two equations and replace one of the letters to get an equation in one letter. So this is, in some respects, similar to the previous question we had on the earnings invested in two accounts. So in that problem, you had to write down two equations too and substitute one into the other to end up with one equation and one variable. All right, so let's go ahead and look at the last example. So this last example is a uniform motion problem. So basically we want to set up a chart where we have distance equals rate times time. So we have two people involved here, Gabe and Elsa, and they're both making the same trip, so they would have the same distance. But anyway, I'm getting ahead of myself a bit. So we have distance, rate, time. And then we have Gabe and Elsa. So let's see what's going on. We're given two times. We're given Gabe's trip takes 2.2 hours, whereas Elsa's trip takes exactly 2 hours. And we're also given a relationship based on the speeds. So if Elsa's speed is 7 miles an hour faster than Gabe's speed, let's call Gabe's speed x, so Elsa's speed would be x plus 7. And then the point here is the distance is the same, so it's kind of the unknown. But we know whatever the distance happens to be, we could just call it capital D. It's the same for both. So that means if you do 2.2 times x, because capital D would be Gabe's R times Gabe's T, it would be the same as if you did Elsa's time times Elsa's rate, because they're both making the same journey. So then we just solve this equation. 2.2x would equal 2x plus 14. Distributing, we subtract 2x on both sides. So we have 0.2x equals 14. And then we divide by 0.2. And we get our value for x, which is the speed of Gabe. So Gabe is traveling 70 miles per hour. And they want to know both drivers' speeds. So we know Elsa's is given by x plus 7. So x plus 7 is going to be 77 miles per hour. So those would be our answers here. This is, again, Gabe's speed, and this one is Elsa's speed. Probably their average speeds, right? They're not going to travel the same exact value, but anyway, this is what the problem is asking for, so that is the final answer. All right, so that is it for the Test 2 review. If you have any questions, please let me know. Thanks.